Hello, we are FTC Team 13201 HAZMAT from Brookfield Central. This is our fourth year as a team, with 10 returning and 4 rookie members this year, grades 9 through 11.
We are a student-led team and have organized as sub-teams which meet regularly. We manage our plans and progress through Trello and stand-up reviews and ensure focus across the 10 pillars of HAZMAT. This year we were challenged to become more financially self-sustaining by our school foundation. We worked hard, did virtual presentations, advocated for STEM support, and were able to impress 3 new industrial sponsors, helping our budget growth by 30%.
We began our season early in summer this year with a demo to Boy Scouts, virtual demos in our school district, and a recruitment drive. We conducted a nationwide first webinar, ran a shadow day for FLL teams to see FTC action, and hosted the 2021 FLL Challenge HAZMAT Remote Qualifier 2 on March 21st. After spinning off 2 new successful teams last year, on International Women's Day, we announced our newest initiative, Project WISER, which stands for Women Inspired in STEM, Engaged by Robotics. Our focus is creating an all-girls FTC team mentored by us.
We participated in the virtual NAC and Wisconsin State advocacy meetings. We are pushing our school for a dedicated first robotics space and an AP course. To support our community throughout the pandemic, our team worked together to make and donate more than 4,000 masks and joined hands with our school's Key Club for an all-school food drive for the Waukesha Food Pantry.
Our objective as a team this year is to learn more engineering design concepts and, of course, do our best in the competition. We set the goal to build the fastest robot that accomplishes all tasks with high repeatability and reliability.
We mathematically modeled the key goal of launching the rings using physics concepts of projectile motion. This helped us to determine ideal launch height, angle, and range of velocities for different targets at different distances.
We used design thinking principles and applied learnings from our experiences last year to come up with our approach, FART. This involved defining the functions for each subsystem, designing them with CAD, prototyping, and testing them, then integrating them with easy accessibility, ensuring rigidity of our overall robot, and finally creating a very tidy aesthetic with clean wiring and good visual appeal.
Our chassis has direct drive mechanism wheels on an A-frame to provide for stability while giving room for the rest of the subsystems to be fit.
The intake design is based on 3 sets of rollers to push rings to our magazine. The front rollers are on a swivel arm that drops, giving us wider reach. The Y-shaped guide system makes it easy for the drivers to pick up the rings.
Our lightweight magazine is a 3D printed block. The interior is designed for quick stacking of rings. It has a unique flipper design to eject the rings through a guided slot and retract while sustaining the stack. These move on a servo-driven elevator with dual pulleys for controlled lift and drop.
The rings are guided from a magazine to a launcher wheel rotating at 3,200 rotations per minute. On one side there's a static guide, and on the other we use encoders and PID velocity control for accuracy and can be launched 3 rings at 1.5 seconds to the high goal.
We designed an arm and servo grip system to move the wobble goal. The unique 3D printed grip shape allows for wide reach and enables us to pick up the wobble goal from any orientation, including when toppled. The beak-like ending can pick rings from the floor as well.
The modular design and assembly ensured easy access for serviceability. We ensured all the wiring is clean and protected, added metal and plexiglass panels for protection, and tuned the robot for performance. Finally, we added our team colors and sponsor logos to finish our robot Requise.
We followed a very systematic software design process, starting from listing out all the use cases and coming up with algorithms. Our platform code structure has subsystem classes, state machine models, and 2 command controllers for gamepad and auto control.
The navigation is built using Roadrunner library. We added automation during teleop for precision. Our unique driver control is based on a single gamepad and incorporates multiple automation steps, poke-yoke logic, and great drive experience.
In our autonomous mode, we can execute all scoring actions and select missions at runtime on the keypad. Our robot is a team player with paths that allow our alliance partner enough space to navigate and choose actions based on their capability.
As you can see, despite the challenges we faced with the pandemic this year, our team has really worked hard across the board to build Requise. We have also done our best to spread awareness of STEM and FIRST throughout our community while having as much fun as possible. And that's us, HAZMAT.
Having amazing zeal while motivating all teams.